Hello, geometry students. In this lesson, I'm going to analyze quadrilaterals using the distance formula. That means how long is a side. If you actually have two sides that are the same length, like for example, DA is the same as CB, then I also have AB being the same as DC, then that would actually be one of the requirements for a parallelogram. If you look at this, squares and rectangles obviously have the same distance. This is congruent to that. That would be congruent to that. Of course, for a square, all four would be congruent. On an isosceles, we'll skip down to a rhombus. I know that all four sides are congruent on a rhombus as well. It's just that their slopes are not the same. Furthermore, on an isosceles trapezoid, I know that those are congruent, but the other remaining two are not. So if I can prove one pair, then and parallel. So this says number 4 because it's a continuation of the previous one. And it is pretty much the same thing, -5, 1. I'm going to go ahead and graph this. We already know what the shape is because we just did this in the previous video. If you're interested, go back and watch it. I can see from graphing it that it looks like it's a rectangle. Whoops. That B is definitely not in the right location. Now it looks like a rectangle. But I can actually say, instead of doing the slope like I did on the last one, I'm going to use the distance formula. The distance formula, in case you've forgotten it, is x plus x squared plus y squared, all of that under the radical. It comes from the Pythagorean theorem. So you can use the numbers if you want, but frankly, it's so much easier to just use the Pythagorean theorem. So for example, I'm going to find the distance between A and B. I'm going to compare it with DC. The distance of AB, I'm going to create a slope. I'm going to create a Pythagorean theorem triangle. So if you look at it, it looks like this. I'm trying to find the hypotenuse, and I see that this is 3 units, and that's 3 units. Well, if you use the Pythagorean theorem, it's like saying A squared plus B squared is equal to hypotenuse squared. But I don't want the hypotenuse squared, so I take the square root of both sides. This is the distance formula. It's A squared plus B squared square root. While I'm still on that thought, I'm going to go ahead and do DC as well and show you that DC is A squared plus B squared square root. Quick calculation here shows that this is, I don't remember what 3 squared times 3 was. 4.24. So I know I actually have two sides that are congruent. Congruent meaning equal. Well, I'm going to check the other sides. And again, I can use the distance formula if you want to, but frankly, it's so much easier just to create a right triangle. I'm trying to find the hypotenuse. This is on both of these, and I can see 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. It's actually 6. I didn't count one of those, but you can see my triangle from right here. If you can create a right triangle, do so. It's so much easier if you have a picture. So the length of BC is equal to the square root of 6 squared, A squared plus B squared equals BC squared, but I don't want BC squared. I want BC, so I take the square root. That's why it looks like the distance formula. And now, if you are a formula person, just go ahead and plug it in. Find AD as well. If you're a formula person, just find the coordinates. You already know them. A and D, plug them in. But again, it's just so much easier to use a Pythagorean theorem triangle, which I know that's also 8.49. That's actually determine whether the quadrilateral is a distance, and I indeed have proven that ABCD is a rectangle Actually, I've only proven that it's a parallelogram at this point, because I have two pairs of congruent sides. Equal sides. I would need to do a little bit more to prove that it's a rectangle. That'll come up later. Determine whether this is a rhombus. A rhombus must have 4 equal sides. So you can go straight to the distance formula and plug this in. It's a squared plus b squared equals hypotenuse squared. I hope you didn't notice that mistake I made. So, but I'm going to go ahead and graph this. -5, +1. That's my W. -2, 4. That's my X. Over 1, up 1 is my Y. -2, -2 is my Z. If I actually look at this, it almost looks like a square. But I'm trying to prove merely that it is a rhombus. And a rhombus must have 4 congruent sides. There's really nothing to highlight here. I just need to find all 4 sides. So WX, then I'm going to go find XY, then I'm going to find YZ, and finally wrapping around, I'm going to find ZW. But again, I want to do a slope triangle. I want to do a right triangle every time. So if you look at this, there's my right triangle. It's 1, 2, 3, 1, 2, 3. And I'm trying to find the hypotenuse. Well, that hypotenuse WX is x minus x 3 squared plus 3 squared. I think I already found that. 4.24. We'll do the same thing for XY. XY is 1, 2, 3, 1, 2, 3. It's a squared plus b squared equals hypotenuse squared, but I don't want hypotenuse squared, I want hypotenuse. YZ, down here. Here's a triangle. It's got 3 by 3. I'm trying to find the hypotenuse. So once again, conclusion, WXYZ is a rhombus because I have 4 congruent or equal sides. Now it's possible it could be more than a rhombus. If I use the slope, I could probably prove that these sides were parallel and actually prove that it's a square, which indeed it is. And that's what I'm going to do right now. I'm going to plot this again. And I'm going to prove that the diagonals I could find the slope, but I actually want to use the diagonals. And this is going to be quite easy, because if the diagonals are equal or congruent, then I can prove this is a square. I don't really need to look at the slope. Of course, the diagonals, one of them is xz, so the length of xz. Notice I didn't write the distance formula because I don't need it. I can just count the blocks. How long is this? Well, just count the blocks. 1, 2, 3, 4, 5, 6. It really is 6. How about WY? Same thing. Just count blocks. 1, 2, 3, 4, 5, 6. Conclusion, WXYZ is a square because I have 4 congruent sides. I found that in the previous slide. And diagonals are